Good afternoon and welcome to one more webinar from Telerik India. So today we're going to be looking at a very specific topic, kind of which is hot for given that Microsoft build is happening at the moment. So we have already finished day one of build and there's a lot of announcements. Microsoft will be focusing more on what we call as Windows 10 Universal Windows Platform. A lot of things are happening around this particular subject. So we thought, what better way to just let you know what exactly is UWP, how do you use it, and then what we have as Telerik as a company. So today is going to be introduction to Windows 10 Universal Windows Platform, kind of a developer's guide to Windows 10. You don't need to know the full operating system, but rather as a dev, what can I do? What's all this kind of funda about, UWP? What is this buzz about? Write once, run everywhere on Windows platform, those kind of things. So that's what we're going to be taking a look today. So it all starts, I mean, if you have been following the Microsoft landscape, you would know that they were very, very disparate products. So you, at the one end, you had the Windows itself, you had the Windows desktops, and then the what we call as the desktop laptop PCs, and then at the other end you had the Windows CE, or I come from the era where I've seen Windows PDS. We used to have an operating system called as Windows CE. That's the OS that used to run on those PDAs, the portable digital assistants. And then of course Microsoft had the gaming console coming in, so that was called as Xbox 360. So there were three different things, and all these three different things were actually having three different operating systems, or although we used to call like, oh yeah, Windows CE runs Windows, or for that matter during the time frame of 2012, I remember still Windows Phone was just launched. It was codenamed Mango. We used to call the version name was Windows Phone 7.1, and I wrote three or four applications, and then Microsoft was running a competition, and then if you write three or four apps and showcase it to Microsoft, they would give you a Windows Phone. And then I was completely pumped up because I did not have to learn anything new except Visual Studio and then maybe the new SDK. But the problem and then I won a Windows Phone, and then I loved very much. But the problem was, now you had Windows, and then you had Windows Phone, then you had Windows CE, then you had you had Xbox 360. Maybe I had a idea which could actually go on everywhere because it's a Windows, right? At the end of the day, it's all running the flavor called as Windows. But there is something that each operating system has, which is called as the core or the kernel, and these were completely different. As you can see here, Xbox 360, the middle purple line is actually the Windows core, and then you had the Windows Phone kernel coming in, and then Xbox 360 has its own kernel, and they were never they never unified themselves, right? So you had to write three different applications and all those things. Then Microsoft started thinking about unifying things. So when did that happen? Well, Microsoft came out with something called as Xbox One, then released a new operating system called as Windows 8, then released a new phone operating system called as Windows Phone 8. Now what happened here in this convergence is the Xbox One, the Windows 8, the Windows Phone 8 all started using the same Windows kernel, right? So the core kernel was made the same. It was the same, and then there was no difference on that. So now we started seeing a new era of applications wherein I could write kind of an app which could run in multiple places. Maybe I'm from so many disparate applications, I was coming down to two applications. So in fact, yeah, we still had two different apps, meaning if you had to write an applications for Windows 8, and then if you had to write applications for Windows Phone 8, the UI was still different. The Windows Phone 8 was still running Silverlight runtime, whereas the Windows 8 provided you you could write it in JavaScript, you could write it in Silverlight, you could write it in C#. So those kind of stuff. So the convergence was still not yet there for the complete mobile applications. So what they did was they released Windows 8.1, and in the Windows 8.1 they unified the mobile and the desktop OS, and now you have Windows Phone 8.1 and then you have Windows 8.1. So the app could now be only one app written for your desktops and then phone. And notice again the Xbox was on a separate kernel. The unification was going on, but you still need to write one app for Xbox, one app for Windows 8, and then Windows Phone 8, right? But with Windows 10, they currently have the complete unification, meaning you take any family of Windows 10, they are all running the same kernel. There's no difference at all. Meaning I'm talking about Xbox One, I'm talking about your Windows 10 laptop, desktop, tablet, Windows 10 phablets, Windows 10 phone. Not only that, HoloLens, fantastically, a creative device that's coming up. It's a holographic experience that you get. And not only that, the IoT core or IoT devices that you can think of, right? You can take a Raspberry Pi 3, you can take a Raspberry Pi 2, you can take an Arduino, you can load what is known as Windows 10 IoT core, meaning there is a specific version of Windows 10 which is made or which is developed exclusively for these small devices, but it shares the same kernel. So I can write today a one Windows 10 application and I can rest assured that it runs on Xbox One, it runs on Windows 10 desktop, laptop, phablets, tablets, phone, and IoT device, right? There are a bunch of cool demos available that you can actually go on Channel 9 or MSDN and then take a look at that. You can load a Windows 10 IoT core operating system on a Raspberry Pi, open up your Visual Studio, create a Windows 10 universal Windows platform application and directly deploy it onto a Raspberry Pi, and then you can see the same visual thing coming up on a Raspberry Pi. That's as cool as it can get with the Windows 10 the ecosystem itself, or the whole the platform. So this is what I was talking about, right? So you have phones, you have phablets, you have small tablets, you have large tablets, you have two-in-one, meaning there are certain devices which act as if like they are a tablet when you're holding it in the hand, whereas when you keep it on a desk, it's a kind of a laptop. Of course, you have your classic laptops, like the work stations that you can think of, and then Surface Hub is like, I believe it's a 70-inch or a 110-inch huge monitor that you get, and then that's called as a Surface Hub, which is usually used in big corporations to kind of team collaborations, all those things. And of course you have Xbox One and the newest things like holographic headsets and then IoT. So this is all running on Windows 10. Now you can think, you can imagine writing one application and making sure it runs on every of these devices that I'm talking about here. So that's what Windows 10 UWP app is all about. You write once and you can just directly deploy it onto any of these devices. And I think if I read it correct yesterday in the build, Microsoft did announce, like, there are close to 2 billion or 3 billion devices which will be on Windows 10. So you can think about the potential, you can think about the the opportunities that you have. If you have a good idea, you can actually take that good idea into any of these UIs or all of these UIs. So that's what the opportunity lies for you if you're a developer or an enterprise, right? And this is what we call about, from now onwards, it's no more which versions of Windows that you are running. It's going to be what Windows device family are you running on. Are you running on phone? Are you running on tablet? Are you running on desktop? Are you running on PC? Are you running on HoloLens? And tomorrow maybe Microsoft may come out with another device family. So that's the beauty of this particular platform. No more you're writing against screen sizes, no more you're writing against what do you call as a what device it is. Rather you're writing against a family of devices, right? They call it as multiple device families. So there is devices plus IoT, then there is mobile, then there is PC. So notice what is happening. I do not have to worry about the form factor, right? So a two-in-one, like a tablet, laptop, a desktop, or a traditional laptop, they all belong to a family called as PC. What is a mobile family? Well, anything which is like a phone, anything which is like a phablet, anything which is like a small tablet, yeah, those are all combined, or those belong to what is called as a device family called mobile. And of course, devices plus IoT, any uh, small devices like Raspberry Pi or Arduino or anything which for that matter which can run Windows 10 IoT core is going to be classified as a devices plus IoT. Of course Xbox is going to be its own, it's an Xbox One, and of course you have the holographic headsets coming up, right, Surface Hub. So now this is what you're going to be writing against. You're not writing against a phone or a desktop, rather you're writing against, am I on running on mobile? Am I running on a PC family? Am I running on an Xbox family? Am I running on a Surface Hub? Am I running on a HoloLens? That's it. Based on that, of course, due to the varied nature of these hardwares themselves, you will not have all the APIs available. So all I need to check now is, hey, is this API available when I'm running on so-and-so device family? If yes, go ahead, invoke that. If not, okay, I'm going to fall back to whatever I can get from this particular device. So that's how your thinking will be, or your coding will be from now onwards. So it's all universal apps, one universal Windows platform. You get an adaptive user interface. You can use natural user inputs. In fact, yesterday in the build keynote, I was looking at the inking capability that Windows 10 brings in. Brilliant inking capability. If you are ever have seen like a sketch artist trying to do a sketch on a tablet, oh, this feels as if like he's actually writing it on a pen and paper. So that's how close they have got with respect to the inking capabilities. And one SDK, that's the biggest thing as a developer. You know, I'm a dev. I've been coding on Visual Studio from last 14 years, and that's what keeps me inside Visual Studio. Anything that comes up in Microsoft, I do not have to leave my day-to-day editor, right? It's still Visual Studio. I sit through the Visual Studio. I have only one SDK. I have only one tooling. I do not have to worry about anything else, and I can actually go deploy on a phone. I can deploy on a tablet. I can deploy on a desktop. I can deploy it onto a IoT device, all through my single tooling. That's the Visual Studio, right? And since we are going to be one universal Windows platform, one Windows, and one app that goes everywhere, so we have one store, one dev center, meaning you do not have to worry about different stores, because when Windows Phone and then Windows 10 Windows 8 started, we had two different stores. You know, in order to publish for phone, I had to go to phone dev center. In order to publish for Windows 8 desktop, I had to go to a different dev center, and then it was confusing. We kept telling them, you know, you got to unify, and now we have that unification through the one universal Windows platform or the Windows 10 UWP platform. So this is how it's going to look like in from a very high level, 10,000 feet. You have the Windows 10 operating system, and of course you have your traditional WPF, .NET, C++, runtime, you know, all those things. And this is how it's going to look like when it comes to universal Windows platform. You still have the .NET languages, you still have the C sharps, you still have the so XAML, DirectX, HTML, everything will be coming in. Plus there are the bridging technologies also that will come up. Like for example, there's already a bridge for Objective-C. We also have a bridge for the Android version. You know, those kind of bridging technologies will always be there. But this is how, at a very high level, the Windows 10 platform looks like. So universal Windows platform, what exactly is it from a actual development perspective? Well, it's a single API surface. You get the API, guaranteed API surface. If you see there, I have the desktop device, I have the phone device, I have the Xbox device, but all of these are running the Windows core. The core kernel on all of these devices is the same, right? So the UWP is built on the core. So that means the whatever APIs that I can think of is guaranteed there on that particular day. It's going to be the same on all devices. Of course, some devices will have their own capabilities, extra capabilities. For example, phone will have its own extra maybe a API that's not available on an Xbox, or Xbox will have an advanced API which cannot be there on the phone. Yes, those those specific capabilities will always be there when it comes to different devices, but Windows will make sure that I get that core whatever runtime that I'm requiring to run on all these varied devices. It's going to be the same across. And of course you will get a whole lot of APIs, right? You know, the storage, the speech and Cortana, authentication broker, background transfer, background task, many more. All these gonna be the same. So here's the beauty of the Windows 10 UWP. I do not have to worry about any other UI language. If I know XAML, I'm rest assured that's what it's going to go through across the device families. Why? Because Windows 10 Core will make sure that UWP will support XAML everywhere, because that's what the whole funda is all about. XAML, you just go create your UI in XAML and then package it, run it on a IoT device or run it on a HoloLens, run it on Xbox One. Everywhere you're going to get that whatever rendering technology is there, and I don't have to worry about anything else. So apps don't target Windows 10, but rather apps target the UWP, or the platform itself, right? So that's what it's all about. Uh, you're not writing against Windows 10 on a desktop, Windows 10 on a phone, Windows 10 on a IoT, Windows 10 on a maybe HoloLens. No, you're not writing like that. You are writing against the universal Windows platform that's running on different device families. And the UWP guarantees you the APIs that you need. That's the basic fundamental of this. So this is how the dependency will be there. So you will be able to tell that, hey, my target device family is so and so. I support a min version which is 10.0.10.240. So that's the RTM build version of Windows 10. And you can also actually say like, oh, I've tested actually the max version is 10.5, which is nothing but if you're an insider, you would have got the latest, fast ring build. So this is how you now target the device families. And of course, the UWP platform does not depend on the Windows 10 release cadence or the release cycle, right? Microsoft now what has done is, if it thinks that there is a necessity of some feature to be published on, to be pushed on to the device families, well, they can ship it, or the UWP can be updated as a separate cadence, as a separate release cycle. It doesn't depend on the OS itself. So meaning Microsoft doesn't have to ship a Windows 10 update to update UWP. No, UWP can be updated on its own cadence, or this one. And this is what it is. It's when you come to development, it's a single library, right, or single binary, right? You write your Windows app, and that Windows app is targeting Windows platform, Universal Windows platform. The Universal Windows platform is running on a core. The core can run on a desktop or a phone or an Xbox. That's it. I don't have to worry about that. Why? Because my Windows app is targeting UWP, and then UWP will make sure I get the APIs everywhere. And notice the file new project creation dialog box that I put up here. There's only one template which says Windows Universal blank app. I mean, of course, as of now, Microsoft has released this blank template, and it's up to you. You can create your own templates to kind of speed up things. But this is the starting point. That is all you get. You do not go and then say like, oh, I need to build a phone application. Oh, I need to build an IoT application. No, you don't have to. That's the beauty of the UWP. You start saying, I want to build a universal Windows application. That's it. Full stop. And then rest assured, this app, since it's targeting UWP, will run across all the families. Let me see if I have any questions as of now. And yeah, I think we're good on the questions so far. Not critical ones, so I can take them at the end. So that's what it is. And okay, let's look at well, let's quickly talk about what exactly is that, devices, or let me see what I had. Yeah, so this is how it is. One Windows, right? Uh, Remember I talked about Windows family. So from now onwards, you're not going to talk about phone or a desktop or a laptop or nothing. It's going to be what we call as device family. Which device family do you belong to? So under the hood, what Microsoft has done is, as the devs for us, is, hey, let us know what you're targeting. So there's only one thing called as desktop. So when you say desktop, that can be a PC, that can be a two-in-one, that can be a laptop, right? So like that. And when I say mobile, so that's going to be a little different. So these are all the small devices, like maybe 7-inch, 9-inch devices, or 11-inch devices, like a tablet or a phablet or a phone. Of course, Xbox will be currently has only one SKU, which is Xbox. IoT will be like you can bring in. So IoT SKU, there are two things. Band, what Microsoft Band, you all know, it's a fitness band. That has a UI, so I can write a universal Windows platform application to run on Band. That's how cool it can get. And not only that, headless, IoT headless, meaning Raspberry Pi, no UI that you get. You need to attach an external monitor, right? So like that, this is how you get the different SKUs, or to just to get an idea of what are the different device families that we will be programming against. So that's what I meant by separate devices will have their own additional capabilities that they will bring in. So each family offers its own shell and adds features to those it inherits. So everybody inherits from a common core, and then each family will add up, or each family will provide its own additional capabilities. As I mentioned, Xbox may have a feature which you do not find on the phone. That's because the Xbox device family went ahead and then inherited the same core but added an additional capability, whereas the phone, again, it inherited from the same core, but it adds whatever its phone related features that you can get there. And the biggest thing about UWP is adaptive design. So Microsoft has gone ahead and then created certain controls, or the whole concept of this whole single app running in multiple screen sizes, multiple devices, is based on this adaptability of your UI. There are certain controls now which can be told how to adapt themselves in different screen sizes. For example, if I'm running in 720 pixel and below, I want things to stack up one below the other. But if I'm running anywhere around 1080p and greater, I want them to stack next to each other like a vertical, like a columns, whereas 720p and then below, I want them to be like a rows. So these kind of things are already built in. There are certain controls that are, one example that I'm going to show is I can take a list view and then create the list view in such a way that when I run on the phone, I get different rows, whereas when I run the same code on a Windows desktop family, I'm going to get different columns, because on a desktop family, I get a huge screen real estate, whereas on a phone, I don't get those real estate. The real estate for me is very limited. So that's what we're going to see in one of the demos. And many controls handle basic responsiveness. That's what the core thing is about. So the like list views, the grid views, so they have a little bit of responsiveness already built in. New panels have been brought in. So for example, there is something called the relative panel. So that means all the children's of relative panels are positioned relative to somebody else. For example, I can have a grid, and then I can have a second grid, and I can tell that, hey, second grid, I need you to be placed right side of the first grid. Yeah, that's relative positioning. So at runtime, I can change this relative positioning depending on where I'm running, right? And the smart layout adjust to large changes like visual states. So this is nothing new. Many people who have done core WPF will understand what visual state is all about. So XAML as a technology, as a UI technology, has this fantastic feature called as visual states. I can create multiple visual states and then trigger that visual states based on maybe a screen dimension, or I can trigger that visual state based on some programmatic code related stuff. So I can write a visual state saying like at 720p I want this visual state to be applied, and inside that visual state all I do is I set certain dimensions saying like I want this header to be this height, I want this font of this particular text block to be so and so height, sorry, size. So like that I'm setting certain dimension depending on the screen sizes. So, and that is made possible using this visual states. And it's if you have done blend, or if you have done a lot of extensive WPF work, it will be very easy for you, and it continues on because the UI technology is XAML. It hasn't changed. And of course, tailored design, you can actually, although we say that you can write the app only once, you can write the screen once and then it can run across the device families. If you think that you need a specific tweaking of a screen for a specific device family, well, there is a feasibility of that too. You can actually go in and then create a page exclusively for phone, and rest of them follow this the same look and feel, or rest of them follow the same layout. Whereas when your app is running on phone, you need a different layout. Yeah, you can do that. So that's the tailored design concept of UWP. So this is what adaptive designs are all about. As you can see here, notice that the name and then the the buttons on the Skype, the 4 buttons and then the hang up button, the red color button. Notice that it is very bold, big in the phone. That's because on a phone your thumb can easily reach the bottom portion, and you need a bigger area to click. So that's why you see that particular button being big. Whereas the same Skype app, when I'm looking at the desktop family, right? Take a look at what happens. The button has gone to a round button, and then it is very small. Why? Because on a desktop, you always either use a mouse or the touch factor is much bigger in a the desktop as a family. Similarly, this is fantastic. So if you take a look at this, if you are on Windows 10 phone or Windows 10 mobile and then or Windows 10 desktop, there is this new applications called as calendar, mail, all this stuff, and these are all UWP apps out of the box, meaning it's the same application that you get on a Windows 10 mobile, and then it's the same application that you get on a Windows 10 desktop. And notice how the UI has been completely changed, right? Of course, this is all made by making use of this adaptive design, adaptive layouts, adaptive UI, repositioning. Of course, that's the whole funda of this UWP, right? I write once and then I just take a look at where am I running. Am I running in a phone? That means 720p. Oh, okay, I don't need the left side bar. Let me hide it, and then I'll get it only when user needs it. And then, oh, I cannot see the full grid. I cannot show the full grid. Notice it has automatically gone into an agenda view on the phone. So like that, this is the experience. It's all about giving experience to the end user. And biggest thing about Windows 10 Continuum, if you have just a phone, let's assume you have a Windows 10 Windows Phone 10 mobile device, you can actually connect that to an external monitor using a dock, and your phone can now become a complete laptop. Why? Because the Windows Phone 10 is running the Windows 10 core, and all these whatever productivity apps that you have, for example Office apps, mail, calendar, everything is UWP, right? So the moment you attach an external monitor and then you open up the Excel or PowerPoint, they know how to adapt to that bigger screen, and then they will provide you a complete laptop experience. So that's the biggest factor for me, because assume I'm currently on some business meeting or something, and then quickly I have the file, but I want to quickly modify something in a PowerPoint or something. So all I can ask is, hey, just give me a monitor, so I can just connect using my dock to that monitor, and then I can quickly edit that PPT, save it in the OneDrive. My team can get it back. Possibilities are kind of numerous with Windows 10. So of course, so let's take a look at now. Let's I think this is the time for maybe a little bit of demo. So what I'm going to do is I'm going to switch back to I was in the middle of something, so I'm going to just show. Let me see if there's any questions anymore. What about old MS projects for Windows Phone 7, Windows Phone 8.1 and Windows 8 store apps? Are they upgradable to Windows 10, or do we have to rewrite the apps for Windows 10? Currently yesterday in the build, what they have announced is if you have any Win32 application, there's a converter available to convert them to UWP. But if you're coming from WinPhone 7, WinPhone 8.1, Win 8, Win 8.1, there's already a migration, I believe in the MSDN, you already got the migration strategy, migration paths. So you will have to migrate your old applications to UWP apps. There's no straightforward, like you take a Windows Phone 7 project and then retarget it into Windows Phone 10. No, that's not going to work, because Windows Phone 7 had a different core or different kernel, right? So and then Windows 10 is completely different kernel now. So what you will need to do is, you can actually do a lot of reuse of your code that you have, but you will need to kind of recreate the project, get all the data that you have, and then kind of start from there. Okay, so now let's get started. So what I've done is I've already gone ahead and then went into Visual Studio. So I'm currently running Visual Studio 2015. By the way, if you want to do anything on Windows 10 UWP, you got to be on Windows 10 OS, and then you need to have Visual Studio 2015. I believe 2012 is also possible, but it's always best to be on the latest and greatest. So currently I have Visual Studio 2015 Enterprise, but you can go download Microsoft's Visual Studio 2015 Community Edition. The Community Edition is free for, I believe, individual developer. For example, you want to just try out and then practice and then understand how this thing is. Yeah, so it's free for you. You do not have to pay anything. Whatever I'm going to showcase in Enterprise Edition, you can do the same thing in Community Edition. Not a problem at all, and then you can get going. And notice here, as I said, there's only one project template which says blank app, right? So let me do this. So I'm going to start a new Visual Studio. So I'm just starting my Visual Studio 2015. I already have 3 instances, so let's see. Okay, so I'm back now. So what I'm going to do is just go and then say new project, and I'm going to say blank app, so app 3. So the project has been created, and of course, as usual with any Visual Studio project, what you get is a Solution Explorer. But now notice here, I do not have anything else. So let me get my zoom it. So if you zoom it and then, okay, where did my Solution Explorer go? Yeah. So if you see now, it says Universal Windows, and then notice here the project is as minimal as it can get. There is no more Windows 8, Windows Phone 8 project. You don't see any of those things. Why? Because now we are targeting UWP. So that's why it says Universal Windows. And if you look at the references, this is interesting for me, right? There is a new .NET runtime now. It's called as .NET Core. The Windows 10 core runs .NET Core under the hood, and remember I talked about we target universal Windows platform. So this is all it is. And notice here, if anybody is working on Microsoft technology, you should know what this is. This is a NuGet package, right? So the dependency for this project is actually a NuGet package called as Microsoft.NET Core.Universal Windows Platform. That is all is required to run anywhere. And then of course the Universal Windows SDK, the runtime that you need, and Visual Studio is set up for that particular stuff, right? So if you take a look at the main page, there's the coding experience, or if you've already done certain amount of Windows Phone or Windows 8, there's nothing that changes for you now. It's the same XAML. So it's the same page that you create, it's the same grid that you create, and then everything is the same. There's no change for you at all. Only thing that has changed is the way now this application, the application is packaged, and the way this application will be running. So now there's no more a .xap file for Windows Phone, and there's no .apex or whatever we used to do. So there's only one package called as apex now. .appx. That's what gets generated, and that's what's get deployed onto the stores, and that's what you get. That's what you download from the store itself. So now I can just come in here, and then I can put a text block. Nothing changes, right? So I can just say hello world, right? And nothing changes. So now what I can do is, notice here what I get now. So I'm getting Windows 10 simulators because so these are the Windows 10 mobile simulators that you will need. I'm going to be running this 4-inch 512 MB mobile emulator first. So let me show you this. Oops, I picked up the wrong one. Okay, let me stop it. So I need 512 MB because I already have it open. So let me show you this. So on the front, what you're seeing is my Windows 10 mobile emulator, which is running 10.586, 10.0.10586 version of Windows 10, which is the latest in terms of the builds. So now what it is doing is it is taking that particular XAML application that I wrote, and then it's going to now deploy it onto my emulator now, and then my emulator is Windows 10, right? It's running Windows Phone 10. So let's see, the deployment is complete, and there we go. So the application is launching, right? So nothing changes now for you, right? It's the same XAML, you wrote the same grid, you wrote the same text blocks, and then I'm writing the same hello world. Now here is interesting now. Now I want to run this as a Windows 10 desktop application. So currently my laptop is a Windows 10 OS running the latest and greatest builds. I'm on the fast ring of the Windows Insider. So I get, as and when the dev team releases a, puts up a release, it just comes onto my machine. So I'm on the latest and greatest of this. I think my version is build 14279, which is the latest one. So now we saw it running on the Windows Phone family, or the phone family. Now I'm going to go run it on a desktop family. So I'm going to pick up local machine, and I'm going to say run. So now what you will see is this same application is now getting deployed onto my laptop. So there you go, it's registering the application, and then done, deployment is done. Now I should see the application coming up, and we have the application coming up. And it's going to do the same hello world. So you're not able to see the hello world because since I'm running a debug version, I mean I'm doing a debug, the debug puts up a frame counter in all this at this left hand area, and then that's why you're not able to see that. But notice here it's the same. As I said, you're getting more screen real estate here, but the app is the same. There's nothing changed. So maybe I'm going to go do this. So let's say I'm going to say margin 50, or maybe let's do 100. Yeah, and then we'll say horizontal alignment center, vertical alignment center, so that it comes and sits in the center. And maybe I'll do a font size to be 40. Okay, maybe a little less. A little less. Yeah, so now what I can do is I can run this on a local machine, and you will see the hello world coming in the center. I just wanted to make sure that you get that it is the app which is running. There you go. So there's the hello world. It's on the center, right? The same app, now I can just go and then run it on mobile. So let me change it back to 4-inch 512 MB. And it's going to be the same. So as you can see, hello world is the same code which is running in 2 device families now, and I'm not set up for let's say a IoT device. If I had set up for IoT device, meaning if I had a Raspberry Pi 3 or whatever running a Windows 10 IoT core, I could have deployed this same hello world application right onto that IoT board, right? You can think about a lot of the possibilities there. So mind you, Windows 10 IoT core is free of cost for any devices less than 7 inches, I believe. So meaning if you have a Raspberry Pi, you do not have to pay for the OS. The OS is free. You can just go download Windows 10 IoT core and put it onto the Raspberry Pi, take a Visual Studio 2015 Community Edition, create a UWP app, deploy it onto Raspberry Pi. Maybe you have a Raspberry Pi having a lot of sensors. Yeah, just create a nice dashboard by using tools like Telerik. So we have a bunch of the visualization gadgets that we are gauges, charts that we provide you, which you can use in your UWP app. Now, this is Hello World, but let's go a little bit deeper, and then I'm going to show you something that I've been building. um, so this is an application called as Cookbook. So what I've done is I've already gone ahead and then created a static data here. So I'm going to create recipes or kind of my own recipe app. So here you can see, like, I have a recipe. It has a title. It has an ingredient list. It has a picture. So I have stored the images, everything in the application itself. I have the steps also, the instruction, the image for that instruction, blah, blah, blah. So as you can see, this is nothing but a recipe, right? And then each recipe belongs to a category. So what I want to do is, initially I want to show the categories coming up, and then when I click on a category, I want to get into the recipes that are available under that category. Then when I click on a particular recipe, I want to then look at the complete instruction of creating that recipe, right? So what I'm going to do is, first I'm going to go ahead and then say, like, I want to run this as a desktop families, because I want to show a couple of things that happens when I do this. Remember, I talked about adaptive UI, adaptive layout. So that's what I want to showcase here. So this is just getting built, and then there we go. So we have the cookbook, the cookbook is getting installed on my machine now. Notice I'm running like 1600 by 900, what do you call, the resolution that I have is a 1600 by 1900, and on the top what you're seeing is actually pivot control. And those of you who come from a Windows Phone background, I used to love pivot very much, because it gave me a kind of a UI wherein I can bring in different screen or different information paths directly onto my home page, and then people can just flick around and then see, and then just dive into any information they wanted. So the same pivot is now available across the families now. So it used to be only Windows Phone, the phone family, but now with UWP, what they did was they exposed this particular pivot to be adaptive, to be responsive, meaning it knows how to render itself on a phone, it knows how to render itself on a desktop family or an Xbox family, all those things. Don't worry about the colors and all those things. These are all certain styling, resource styling that I've done, and then brought those concepts. What I want you to notice here is, when I'm running on a device, the desktop family, notice I have a pivot, and notice these are known as the action bar or the command bars. Manage categories, add recipe, shopping list, search, and everything. Now, when I resize this, keep looking at this particular list view. So this is actually a list view. What you're seeing here, appetizers, bread, soups, everything, whatever you're seeing is a list view, and it knows that it has horizontal spacing available, so it has gone ahead and then itself automatically laid itself horizontally, right? But if I kind of keep resizing my width, notice what is happening. The list view automatically will go ahead and then adapt itself to whatever screen size, and notice now it became 2 columns and then multiple rows. Imagine if you're running on a phablet, yeah, the same app without me writing any code will automatically adjust itself to that whatever screen size it is getting, right? And of course I can click on a particular appetizer, I can go inside that, and then notice here, this is how I have laid out this particular screen, right? So there is a the dish picture coming up, and then some things are there, and then here I have 2 columns, here I have a grid coming up, and then I can scroll down. But what happens when I'm on a small screen? Notice what happened, right? So this is where you come in, and then you have to write a little piece of code saying like, hey, you know what, there was a grid, I don't want that grid to be shown on the right hand side, I want the grid to be shown below this main grid. Notice here, this ingredient list that we have has actually come below this main grid that I have. The main grid is showing the picture of the recipe, right? Notice this was on the right hand side, but the moment I go and then change my screen size, right, it automatically went below. Similarly, the instruction list went below. This is where you come in, and then you just have to reposition your whatever layouts that you have, the controls that you have. I don't want it to be on the right hand side. I want to be on the below this particular whatever control, and that is all provided by or done by the visual states that I was talking about. Not only that, notice where the command bar is going now, right? So when I'm on a small device, it doesn't make sense for the command bar to be on the top, meaning it's a handheld device. So you need that to be in the bottom portion of the things. So I mean on the device. So that's why we have automatically placed it to the bottom. So let's quickly take a look at, so I don't have much time. So what I'm going to do is I'm going to touch upon these subtle changes that you will need to do. So remember we talked about the list view first. So let me bring up that. I think I will close down everybody else. And let's bring in categories. So this is the thing, and notice here what I have done. I have placed a pivot, and then pivot now provides you something called as a right header, and in the right header I'm able to see that I can keep a command bar, and the command bar has all the app bar buttons, right? And plus here's a pivot item. So this is the pivot item where I'm showing the list view. The list view is bound to certain data. The data is coming like this, and the template is nothing but putting up the name of the appetizer, I mean the category of the food, and then the certain pictures for that. And this is what I was talking about. There is a new panel called as, or this item, this was always there. So these are some of the things that you will make use of that now. I am telling the list view that its panel, or the panel that's going to show its control the items, is going to be something called as items wrap grid. And I've given it how it should wrap it, the group padding. So meaning between each group, I need a left padding of 15, top 0, right 15, bottom 10. Margin is 0, horizontal alignment left, and then it has to always do a horizontal orientation. That is all I have to do in order to make sure that this list view works seamlessly across the devices. So now we just saw this running as a desktop family, right? So I'm going to keep it as is. Oh, sorry, I'm going to stop it, and then I'm going to run this now as a mobile device or family. So let me go pick up the same 4-inch 512 MB. Same application, no code change. All I have done is I've said use that wraps grid. Right now you will see the same cookbook coming up in a mobile device, and it's going to give you a completely different experience. It's already started the deployment, so let's give it a couple of seconds. And there we go. So it's getting deployed now. And notice even this splash screen, it automatically gets toned down. And take a look at this. This is the same application. Remember I talked about the right header, the command bar was on the top, but using visual states, I'm able to put this down. Yeah, this is what I meant by that. So whenever I'm in a small screen, I can go in and then write a visual state and say, like, if you're running anywhere below 720 pixel, I want the command bar to be bottom, not on the right hand side of the pivot. And not only that, the list view is able to automatically go on and do a vertical. So this is what you need on a phone, right? People should be able to flick vertically. And of course I can click on an item. Notice here, same, the list view now brings you this way. I can click on a particular the recipe, and then notice here it's the same. I have told the instruction to go down, I have told the ingredients to go down, whereas this particular the picture of the recipe should be front and center. So this is all controlled through positioning, relative layouting, the adaptive UI, the concepts of that. So that is all you need to understand as a UWP developer. So let me see if there's any visual states here. I think there were a couple, so that I can show you that. Yeah, there we go. So, oh, this is different. This is for the, let me see if there's any other visual state. Okay, so let me go its code behind. This is another interesting thing. I need to bring this up. So this is what I was talking about, different device families giving you different capabilities. Notice here I'm trying to see if I have a status bar or not. And mind you, the status bar is a concept available only on the phone. It's not available on your desktop family because there's no status bar on the desktop family. Desktop family gives you full Chrome, right? So what I'm saying is, hey, if you are ever running in a device and that device contains a status bar, I want you to hide it. That's all it means. So that means I'm just checking, is that particular feature available? Is that particular API available? If yes, oh, go ahead, do this. Otherwise, that's fine. I don't want you to do anything. And then I'm also looking for app bar, sorry, the back button visibility so that I can, so the desktop family will automatically give you a back button. You can use your the application back button, whereas in the phone you have a hardware back button, right? So the UWP automatically takes care of that. When you're doing a phone, you do not have to worry about the hardware back button. The moment somebody clicks on hardware back button, the UWP takes over, and then if there is a frame stack available, it will go back in the stack. Then what else? So this is categories, and let me see what I'm doing for the app bar. Then yeah, the command bar. Yeah, this was talking about. So if you see here, this the recipes page that we actually saw has that so this is the visual state I was talking about. Notice here, this is how you typically will do in UWP from now onwards. So I wrote a visual state in the recipes page. Remember, I wanted the instructions to go down. I don't want the command bar to be visible, all those things. So I'm saying I created a visual state group and I gave a state trigger. The state trigger is nothing but minimum window width 720. Anytime a screen width is less than or equal to 720, this particular trigger will be run. And what is this trigger saying? This trigger says command bar visibility. Yeah, the command bar should be visible. Bottom command bar visibility should be collapsed. I don't want to see the bottom command bar. And then the right panel, this is nothing but the panel where I had put up the ingredient list, that should be placed left of or the right of this particular relative panel called as left panel. There's a panel called as which shows the recipe picture. I'm saying I want you to place this right of that, right? And then right panel should be below of that, left panel width is 320, left panel horizontal. And so all you're doing is you're controlling the dimension based on where you're running. If you're running 720 and above, I want to do something. If I'm running 720 and below, I want to do something. So that is it. That is all you need to take care as of now, and then everything else will fall into place. That's what we mean by adaptive UI, adapting to the layout, adaptive layout, all those things. And this whole demo is built keeping in mind these subtle things that where should we place what, right? So having said that, now let me take a moment to talk about what we have as a company here in Telerik. So we also have our own custom controls available for you to play around for your Windows universal Windows platform. So this is the adaptive UI for building multi-device Windows 10 apps with one code base. Some of the key features is like, let me go back. Of course, because it is UWP, you can build one app to reach all Windows devices, and then we give you certain other cool things like visualization, maps. If you wanted to map to be running on a IoT device, yeah. So the core Windows 10 UWP SDK does not have anything called as a map, right? You'll have to rely on Bing Maps. Of course, you will get the Bing Map, but what we have is we also have a similar mapping technology, and you can use that. And then this is what I was talking about, advanced mapping capability, direct 2D rendering, very low memory consumption but gives you a maximum performance. And we have an extensive API for the map to do anything. You can do a floor plan, you can do an aeroplane seating plan, stadiums, etc. So that's what our mapping is all about, and this can go into any device family. And data visualization is the biggest thing, right? You want to have the same chart control running on a phone family as well as a desktop family. That's what we do. We give you the visualization which can be used across everywhere, and list view. So what I showed you, the list view, was actually the vanilla list view that's there in the Windows 10 SDK. Ours will be having a much more additional capabilities, like certain other features that we add, like grouping, sorting, filtering, the data engine that you provide to that particular list. That's what we add up in our list views, and then you can take a look at how it is looking here. And uh, you get other core building blocks like sliders, the pickers, the calendars, autocomplete box, which are now universal, meaning the same autocomplete box will work on a phone, will work on IoT, will work on desktop, you name it. So it's a universal control now. And then of course we will give you support during evaluation. Now I already have a ready-made sample that we shipped with it, so I'm going to show you that. First let me show you how this looks in a mobile device. So this is what we call as the sales dashboard, and notice here what it is saying: rotate to view total sales. So if I rotate this, notice we change the UI, right? That's again what is happening is we have a visual state trigger written, and we look for the orientation change or something, and then the moment there's a orientation change and then we see it's a landscape, we would go ahead and then hide some of the stuff and then show some of the stuff, which is in this case the total sales trend. Let me come back to my original position and I can swipe through. Notice here this is actually different charts that are coming up here, and I can swipe through, and then notice this is the different bar charts that are coming in, and this is actually a grid. I can click on a row, all those things. And not only that, I can click on this and then select that, hey, I want to now see 3 months data. So there you go, this is by product. Now let me run the same app as a local. So let me go back to my machine. I've already installed this application on my machine. So now this is running as a desktop family. It's the same controls, it's the same visualization chart, it's the same visualization pie chart, but you see a different things, different rendering, right? That's because now we make use of whatever available space that is there. And notice the total sales, now it can come up like this, right? And I can go in and say, show me 6 months data. Yeah, there you go. So everything changes. Not only that, I can go slide through. If you see here, remember we were showing different bar charts. That is actually a slider. If you see here, I'm able to slide through this particular guy. And not only that, this is the grid that we had. Notice here, this is a grid, right? Plus, I can go and then do a resize this particular application, and then still we will see the app working fine. And then we give you all these rich capabilities in terms of the controls. You can play around. It's available as a 30-day trial. If you can see here, if you see here, try now, you can go download, and then we have all the documentation, support, video. This is what you can do with list views, all those things, data form, the map, input controls. These are some of the controls that we ship as of now in the Q1 2016. The grid is beta, but other than that, everybody else, you will be able to play around with that. Plus, we have another technology called as native script. What native script does is it allows you to go cross-platform, meaning you can create a native Android, native iOS, and recently we are currently in the beta, a very alpha stage, wherein you can write code using XML, JavaScript, and then you will be able to generate native Android, native iOS, and Windows 10 UWP app. So let me showcase, let me bring that up. Native script, I think we have the link somewhere. Yeah, here it is, the link. So this is what we said. Our engineering team has been busy working towards this. So what we have done is we have our native script can actually generate a Windows 10 UWP app. So meaning if you want to go target Android, if you want to go target iOS, you want to target Windows 10 with one source code, with one project, yeah, you can do that with native script. So we already have couple of webinars that we have done for native script, how to getting started with native script, what is native script. I encourage you to go look at our previous webinars and then take a look at this, and this is very promising, meaning now I will be able to write one single source code base and then pretty much target all the major operating systems that are there, Android, iOS, Windows 10, right? So we released this preview of native script generating a Windows 10 package very recently, very alpha. As you can see, March 17th, our engineering team just did a kind of a spike, and then they were able to, the POC, and then they were able to see that, yeah, it is possible. So things are very bright in terms of the Windows 10 as a platform, and we as a company, we are there. We want to make .NET great again. If you are in the build conference, just go to our booth at Telerik booth, and then you should be able to, kind of get your hands on a very cool t-shirt where it says make .NET great again, So that's all I had for today's webinar. I hope you got a complete, kind of overview of what is Windows 10, how do you get started with that, what is exactly the platform, how do you use other controls like, Telerik universal controls for Windows 10, and what are the possibilities, the potentials. I hope I gave you a quick rundown within 1 hour, why you should be looking at this particular platform, and look forward to your presence in our future webinars. I'm going to stop recording now and then get on to the Q&A. Thank you very much for attending this webinar, wherever you are attended today. We hope to see you again.